Okay, so this is the fourth video, and we started talking about the allele. And the allele is actually one out of several molecular forms of the same gene for the same site, which is called a locus, or a fixed location. And we can find locuses in homological or homologies chromosomes. Right? So basically the allele is what we refine to as different characteristics of people. So anything we would look at someone and say, hey, she or he, they are different from me in this and that. The length of the arm, the color of your hair, the color of your eyes, the shape of your nose, the length of your nose, the shape and color of your eyebrows, your muscle mass, your ability to jump, your ability to understand, and so on and so forth. So all those are expressions of certain alleles that you have inherited from your parents, and by the way, up to even 7 generations above you. Okay? So we have the homologous chromosomes. We have couples of them that are sets built or composed out of one maternal chromosome and one paternal chromosome, meaning you got one from your mother and one from your father, right? That pair up with each other inside a cell during what we call meiosis. So each allele might have a unique nucleotide sequence and will be responsible for a different expression of the same genetic trait as we've just spoken. In both the allele, if both alleles are the same, that means that the gene of the child will be what we call homozygous, meaning that you were born and your parents each contributed a gene regarding your eyes. Okay, well, we'll keep with the eye idea or example. Now, if you inherited from both your parents the same allele, for instance, for brown eyes, regarding that specific allele, regarding that specific trait or characteristic, you are homozygous because you're going to have brown eyes. Okay? Meaning that you have only one option in regards to the color of your eyes. You do not have more than one option. Does that make sense? I hope so. But if they are different, for instance, you got from your mother, just for example, an allele for brown eyes, and you got from your father allele for green eyes, then they are not the same, and you are what we call heterozygous to that trait. Okay? Meaning that you have more than one option. Which one is going to be expressed is a different question. So within the same family, the children of the same parents might not have the same eye color, and it doesn't mean that one of them is adopted. Okay? Although it's really hilarious to use it to just annoy your brother or sister, just remember that in genetics, it doesn't prove that you're not from the same family, parents. Okay, so we have a few tables that we're going to play with. I'm going to go over them really quick, but they kind of give you all the options of what we just said about alleles. So, for instance, we have mommy and we have daddy, we have the child, and we have the meaning, right? That's the headlines upwards. So we have the first form of an allele, which we're going to represent with the letters AA. Okay? So the mother has an allele that we're going to call AA. For instance, let's say, and I just made up the symbols. Let's say that if you have the allele that is called AA, you will have blue eyes. Okay? And we can see that in this example, the father and the mother have the same allele, the same form. So they're both passing to their child the information for blue eyes. So this child is homozygous for blue eyes. Okay? And he or she will have blue eyes. On the next slide, we see a different form for eyes, which I decided to represent through the symbol GG. And we see, once again, both mother and father have the same allele for the color of the eyes, in this case, brown eyes, and surprise, surprise, the child is homozygous for brown eyes, and he or she have brown eyes. And now, in the third table, we have parents that have different alleles. The mom is giving the AA allele form, meaning she is offering, so to speak, genetically blue eyes to her children, and the father is offering brown eyes. And now the child has the opportunity or the options to have both blue eyes and brown eyes. The question is, which one is going to be expressed? Okay, so he is a heterozygous for brown and blue eyes. And now we see another option. The mother has both the alleles for blue and brown eyes. The father is offering only blue eyes, so to speak. And the question is, what is the child going to receive? So for instance, the two options that are possible now is that the child will have an AG allele or a GG, because those are the two options. Okay. And now we have another table showing that the mother is offering the AG option and the father has a third option for green eyes. So he has a CC. Once again, how many options do we have? We have AG, we have CC, we have AC, and we have GC. So the child here has four different options of expressing colors in his eyes or her eyes. And now it's even more complicated, because the mother is bringing two options, A and G, and the father is bringing or giving two options, L and C. What is the child going to have? The child can have the following options: AL, AC, GL, and GC, AG, and LC. So suddenly we have 6 options. Some of them are more likely than the others, but all 6 options exist. So when we say that some options are more likely than the others, we're talking about dominance or recessiveness of traits. So some traits are more dominant. For instance, darker eyes are usually are always dominant to recessive traits, but it doesn't mean that they'll necessarily be the ones that express, but they have a better chance, a higher percentage of being those that are expressed. So we see that on the next slide, right? And now we have a more graphic way to represent the idea of the alleles. So every parent has two alleles and they give one to the child, and we do not know which one they're giving in this example, but we know the options, right? And now we see that we have specific alleles, and the child is going to receive one of each, and we have different options. Again and again, if the alleles are the same, we know what's going to go on, be inherited to the next generation. So I'm just going to skip, and then you can see that, for instance, there are unlikely options to happen in case of, for instance, an eye color that we have a really recessive trait. We'll find it in lower percentages in the populations. For instance, there is an option to have gray eyes. Have you ever seen gray eyes? It's really, really rare. That means that it is unlikely for it to be expressed in the next generation of two people. Okay, so I'm moving on, and you see the picture of a child with an unusual trait, and while it's unusual, it is possible. Again and again, you can see an eye that has a ring around it. So that is a mutation, that is a mistake that produces that ring. Okay, now for instance, I've mentioned before that you may find traits that you have that originate up to 7 generations above you. That means that while you look at 6 generations between you and the 7th generation that you have actually inherited that trait from, you do not find that trait. For instance, gray eyes, okay, because it's rare. So let's say that I would have gray eyes. My father and mother don't have it, their parents don't have it, and so on and so forth. And then suddenly I find out that one of my ancestors, 7 generations above me, I'm number 8, so 7 generations above me, that means about 251 people, other people, have not had gray eyes, but suddenly one of them had, and that recessive trait continued to be inherited but not expressed. So it's in the DNA, it's in our family, but it is expressed in a very rare way. Okay? So any trait that you have does not have to be solely from your parents or grandparents. It could have been given on, 7 generations above you. We do not have information as of today of more than 7 generations, to the best of my knowledge. So that's about it. Okay, so you can see that the first generation above you are your parents. So you have 2 parents, right, on the right of the table. And this is a cumulative, the right column. So when you go to see how many people have influenced you 2 generations above you, you have your 2 parents, and they each have 2 parents. So that's 2 plus 4 is 6, and so on and so forth. Let's say, for the sake of the video and peace amongst us, that a generation would be determined as 25 to 30 years. Okay, just for the fun of it. So if you multiply the generations going up between 25 to 30 years, you can see that you might have a trait from someone that has lived on Earth about 210 years ago, between 175 to 210 years ago. Of course, if you want to change the definition of a generation, the years will change accordingly. Okay, so it's just an example. All right, I'm going to stop here. One more video on the way for this presentation. See you later.